In this lesson, I'll give you a little insight into the way a computer works, and we'll do that by adding some binary numbers together. In particular, we'll add 4-bit binary numbers. Like for instance, just like here I have a little six-sided n-gon, and it has just different colors at the corners. Here's blue, and here's magenta, and here's green. And those colors can range from 0 to 255. Well, if you recall, I'll just, 1 byte of data in 1, 2, 3, 4, 5, 4, and then 1, 2, 3, 4. There's 8 bits of information right there, and that would be equals 255 in decimal. All right, so this binary number 1111 is equal to 255 in decimal, and so that's the number that I have specified here for the red color that's currently active right there, like that. And then maybe if I have, say, the number, maybe I have the number 128. As say for the green color, notice how it's changed it here to this orange kind of effect. Well, 128 would be the same as 1, that'd be the 128th bit right there would be turned on, and so then all of the others would be turned off like that. And that's equal to 128 in decimal. So we use binary numbers all the time. Well, the computer actually does, because it's just looking at these ones and the zeros as electrical signals, and they're really just you can equate these to voltages. Just to give you a rough idea, 1 you might say could be 5 volts, and 0 could be 0 volts. So the computer knows when it sees a 1 that the electrical signal is turned on essentially, and when it sees a 0, the electrical signal is turned off, and it's able to compute things based on these differing electrical voltages that are set with these zeros and ones. And it's no longer typically 5 volts and 0 volts. There's all kinds of other voltages that distinguish between a bit that is on and a bit that is off. So, but in this case, I'll just show you how to add some binary numbers together, because computers do this all the time. There's nothing magical about a computer. Us humans, we created all the rules for them. So the basic rule for adding a binary number is when you have a 1 and a 0, you get a 1. And when you add a 0 and a 0, you get, that's wrong, you get a 0. And when you get a 1 and a 1, you get a 0. But then you have to carry a 1. So let's practice with some examples that I have set here. So here we have the binary 1010, and let's see what that is in decimal first. Let's see if we can verify this. Let's see, 1010, if you recall from the lesson on decimal, that would be the same as that would be the 8th place and the 4's place and the 2's place and the 1's place, like that. So this would be 1, that'd be an 8 would be turned on, and a 2 would be turned on for this number. So this number here, I'll just set it out here to the side, is equal to 10 in decimal. And then this number here would be the 4's place is turned on and the 1's place is turned on. So this number here would be equal to the number 5 in decimal, like this. So now let's add them together using the rules, and we go right to left just like you'd use with regular math. So we have a 1 and a 0 is equal to 1, alright, because that's the rule. You add a 1 and a 0, 1 plus 0 is equal to 1. And then for the next operation, we have a 1 and a 0. Well, that's also equal to 1, like that. And here's a 1 and a 0, and that's also equal to 1. And here's a 1 and a 0, and that's equal to 1. Well, these was pretty straightforward, like that. So it says the results of our operation are equal to 1111. Alright, so let's verify what that would be in decimal format. And 1111 would be 8 turned on, 4 turned on, 2 turned on, and a 1 turned on. So that'd be 8 and 4 is 12, and 2 is 14, and 1 is equal to 15. Oh, and there we go. Is equal to 15 in decimal. Alright? Alright, so let's try the next one. So the next one is, well, this is going to be pretty straightforward. So let's make it less straightforward. Let's put this digit here so there's 1 like that. Alright, so now when we go down here, we have 0 and a 1 is a 1, A 1 and a 1 is equal to 0, just like the rule states up here. 1 plus 1 is equal to 0, but then you have to carry a 1 to the next location. Alright, so that means 1 and 1 is 0, and you carry a 1 up here, so then we have a 1 and a 1 here in this column, which is also going to make this 0, like this, and we means we have to carry another 1 over to this column here, and that would be a 1 and a 0 is equal to 1, like that. So let's see what this actually turns out to be for each one of these, see if this is correct. Let's see, I'll just line these up a little bit better. Okay, like that. So this in decimal, let's see, 0, 1, 1, 0, that'd be the 8's place is off, so the 4's place is on, and the 2's place is on, so that's going to be equal to 6 in decimal. And then for this next one, it's going to be only the 1's place and the 2's place is turned on, so that's going to be a 3 in decimal. And then let's see if this actually turns out to be right. So in this case, there's the 1, 0, 0, 1, so that's the 8's place is on, and the 1's place is on, so that'd be an 8 and a 1, and that would be equal to 9 in decimal. Okay, so quite straightforward. You just remember these rules. 1 plus a 0 is a 1, 0 plus a 0 is a 0, and a 1 plus a 1 is a 0, and you have to carry a 1 to the next column. I'll just say and carry a 1 to the next column. Okay, well that's it for this lesson, and I'll see you in the next lesson.